graph data. So in featureization technique, how this graph data also helps us. So if you all in nowadays in today's world, all of you have Facebook accounts. Facebooks have billions of users. Okay, all of we are using the Facebook. So the Facebook data they have collected, it's like a graph kind of data. So let's look like this data. There have the billions of users. So suppose it's one user. Here I have one user. Here I have some things. Here I have another users like that. They are like, and age users are connected to some users by their friends by using their friend concept. Postulate these users are connected to these users. These users are connected. The friends of U1. Friends of U1 is some things look like this. It will be better. Here some users U6. Here some users U7. Right. The friends of U1 is U2. The friends of U3 U1 is U3. Similarly U7. These are the and U4. These four guys are the friends of the U1. Let there have another friends also. Let's first let it U2. So this U3 is friends of U2, and U4 is also friends of U2. U4 is also friends of some. These are these four guys are the friends of U2. Let suppose let's same match U5. Let U5 U2 is the already friend of U2. These are the two friends, and also the U4 is also friend of the U5, and also for U6 these guys are the friend also for U6. Okay, and these are the sample the or graph data. This kind of graph data are used by the Facebook. Okay, so this is called the social networking graph data. There are various network in this today's machine learning world, but this is one kind of graph data that are used by Facebook, Twitter, like Instagram, like it's this kind of these are the called the graph data. Okay, so here this age is UI. Here this age UI is called the vertex or user, and the age between these two users, age between two vertex is called the aged. Is called the friend. The age means here we have used the friend relationship. Relationship means I'm talking about this symbol, the relationship. Here the age between the UI and UJ, these two things, they call the relationship or friends. Or friends. Okay. So these kind of things are the graph data. Now let's see how this graph data helps us to featureize our sets. Featureize something. Let's see. So it would be better if we just specify as our task. What suppose let's our task is through these steps. Let's try to understand how this graph data helps us to featureize something. Let's our task is recommended some new print for some users that I have not used. Suppose let's see here U3 is not friend of U7s. U3 is not friend of U4. U3 is not friend of U5. U6. Now task is but those guys who are not already friend, they have to recommend it some users. Those may be chance to be friend. So in Facebook also we have there have some sections in Facebook recommended friend. They have suggest some friends, suggest based on the some corresponding features. Okay. based on some features. So let's see it how these things are actually working internally. Let's see it. So the tasks that we have recommended, we have to recommend it. New friends for a user UI. Okay, let this is our task. So if you just this task is you look like in another way, it will be we have two users UI and UJ. We have to give the output corresponding to these two users 0 or 1. It will be 1 if yes they have some features that will gives us some recommended these two guys. If yes, then we give the output 0 if these things is no. Okay, this is the actually ML. Now let's try to what kind of features are helps us to give this task to give the output of the corresponding tasks. So there may have past features look like this type. Based on the features, we have give the some output based on the some common features that we have no mutual friend, number of mutual friend between these two users, number of mutual friends between UI and UJ. Okay, the another features maybe the number of paths between let the number of paths between suppose we are now let's consider these two guys u1 and u4 u3 and u4. Okay, how many paths they are have? One path, two path, three path, four path. Okay, so these are the paths between these. How many common mutual friends they are have? We are have two mutual friends u1 u2, u1 and u2. These are the two common mutual friends. Just see it. U2 is common mutual friend between U3 and U4 and U1 as well. Okay, so you can think second features will be the number of paths between UI and UG. So there are lots of features. Now questions arise. So how will decide what features will be our best for our required tasks? So this is based on our domain knowledge, common sense. That based on the tasks actually. It's the based on the tasks. First thing is domain knowledge. Second thing is based on the requirement, based on the tasks, and third and most important, the subject knowledge. Subject knowledge. So if you are a mathematics student, apply math guides or computer science guy, I think you have they are having in a semester, they are have a full long semester course in the graph theory. You have already learned if you are mathematics or computer science guy. So this kind of now on this specific stacks, on the stacks of the graph data, this concept will be helpful. The knowledge of the graph theory that will be helpful to be your specific tasks. What tasks, what features will be better for this corresponding tasks. This knowledge of this subject will be also helpful. And these things, this graph theory are actually a whole semester course. This graph theory is a whole semester course in mathematics and space and a computer science guy. I am not going to discuss everything of the graph theory. I will try to make another series on this graph theory. I'll try if possible. So I will make it surely. I'll promise you I will make it. But now in this series I will give some intuitions. I'll give some what the geometry, how this graph data helps us to build the machine learning features data. These things, this flavor I want to give you. Okay, first try to understand this. When we'll discuss the case study, when you will got your job in some company, so based on their requirement, you have to learn in yourselves. There have lots of resources in today's world. So based on your requirement, you have to learn these things. Okay, but means this kind of thing actually we have to do uh, in the graph theory data, in the graph in the world of machine learning example. So it will be based thing is actually it will be based on our taxes, based on our requirement. Okay, that's the main thing. So let's see what will be the mutual friend. So if you just take this U3 and U4, U3 and U4. How many mutual friends they have? U1 and U2. If you are in if you consider these two features, F1 features, and if you instead of using UI and UJ, if you using U1, U3 and U4, U3 and U4. Then who are the mutual friends between these two? So the mutual friend is U1 and U2. U1 and U2. And path, how many path they have between these U3 and U4? How many path they have? Let's see it. 1, 2, 3, 4. Total 4 path they have. How many path they have? They have total 4 paths. Okay. These are the actual these are help. Just I am giving some examples. These are actually helps us to detect our features. First you have to know the domain knowledge. It's the first most important thing. Second is based on the tasks. What is our requirement? What kind of tasks we have to going to do? Third thing is must have you have to know the subject knowledge in details. Then you will doing this kind of. Okay. So I think you will got the idea how from this graph data how we will find the features onto it just using this social networking. If you think yourselves how these Facebooks are actually give the recommendation some friends. It could be based on the mutual friend. It could be based on the path. It could be based on the locations. It could be based on the your schools, undergrad school, college, like that. It could be based on your interests. It could be based on your think like search history. Search history, like that. Okay, this kind of features are actually internal. So it will be depends on the Facebook how many features they have in consider, what kind of features they have considered. Actually depend on the Facebook's. Actually we don't know what kind of features they have taken, but these are the main technique in every recommendation systems are used. It's simple using this graph data. Okay, I think you got the point.